Given 2 points, A and B, okay, and the position vector has been described for us. So you can see what I've sort of drawn here. Okay, point A is there, and the position vector of A is 11i minus 4j. In other words, to get to A from the origin, you've got to go along that vector, 11i minus 4j, okay? I haven't drawn it properly to scale or anything, right? I know minus 4j would mean going down on the y-axis, so I haven't drawn it properly. It's just a sketch, okay? So it doesn't matter, right? It really isn't important. I just want to sort of get to grips with the sort of geometry of it in my head, but it doesn't have to be perfect, okay? And the point B is 21i plus j from the origin, okay? So I've got that going there, all right? And then if we look at the question, it says determine the position vector of the point C which lies between A and B. So you can see now why I've drawn C there, why I've written C there, because it lies between A and B, and it's in that ratio, isn't it, such that AC to CB is in the ratio 2 to 3. So what I did when I drew this, I did split this up perfectly into 5 parts, okay, so then I could get that ratio. So I've got 2 parts here, 3 parts here, just so I could see it. Now I want the position vector of C, yeah, okay. So to get the position vector of C, I need to know what have I got to do to get to C from the origin, okay. So in other words, I need that vector there, OC, okay. But as we've seen earlier at the start of this exercise, okay, I'm going to need to know what AB is, okay. In order to work out OC, I need to know what that vector AB is, and AB is really easy, isn't it, if you think about it. Going back to what we've done before now, AB going from A to B, well, you can think of the displacement, instead of going directly A to B, you can think of it as going A to O, okay, plus then O to B, right? Now, going from A to O is the reverse of this, yeah? It's going the reverse direction, so it'll be the negative of this. So it'll be the minus of 11i minus 4j in the bracket there. So we want the minus of this, the reverse of this, and then we're going along here, plus then 21i plus j. So this then, well, if I apply that minus to that bracket, I get minus 11i plus 4j, okay, because the minus applied there gives you that. The minus applied to the minus gives you a plus, of course. Minus and the minus makes a plus. Plus then 21i plus j. So then I get that is 10i. And then that is 5j. So that's what my vector AB is. Okay, so I now know what that is. Now going round to answer the question that I want the position vector, don't I, of C. Well, to get the position vector of C, I need to work out OC, yeah, the vector OC. From O to C, well, O to C I can think of as going O to A plus A to C. Okay, now we've seen this sort of thing before, but this time now I'm going to use put it in terms of I's and J's, yeah? O to A plus A to C. Now A to C, of course, well, I know A to C is a fraction of A to B, isn't it? It's the same direction, but it's not the exact same size. It's a lot less, right? So the fraction was 2 parts, yeah, along, out of 5. So we can think of AC as 2/5 of AB. Okay, a fraction of the larger vector AB. So it's a case of substituting in. Well, I know OA is that vector there, so that's 11i minus 4j. And I know AB is that vector there, so it'll be 10i plus 5j. Okay, so take that fraction, multiply it through here, okay, so you get 4i, multiply it through here, we get 2j. Okay, so then in total then, putting it together, I get my position vector then of C. Okay, so I get 11i plus 4j, 11i plus 4i is 15i, and minus 4j plus 2j is minus 2j. There's my position vector of C.